Welcome back to Catalyst Grid. Thanks for sticking around. My name is Kingsley Amafua. The cooling is installed, the power distribution is live and tested, and now we walk into the most valuable space in the entire building. The white space, the data hall. This is what the whole project has been building toward. It's the phase where the construction project finally transforms into a functional data center. The raised access floor system is installed first. It is the foundation of the entire data hall fit-out. IRONGATE's spec requires a 600mm clear void and a high load rating of 12 kN per square meter. Pedestal installation follows a laser-leveled survey. Tolerances are tight, plus or minus 1.5mm across the entire hall. This precision matters. If the floor is uneven, the racks lean, and the hot aisle containment cannot seal. The pedestals sit on the PowerFloat FM2 finished concrete base slab that we established back in episode 7. Every position is documented on a tile schedule, solid tiles for hot aisles and perforated ones for cold aisles. We use 50% perforated tiles at high-density zones, as determined by our previous CFD modeling results. The void is bonded to the earth system. Every pedestal is connected to provide a continuous bonding plane. Hot aisle and cold aisle containment is installed as the racks go in. On IRONGATE, we use hot aisle containment. The hot aisles are enclosed, and exhaust air is channeled directly to the CRAH return path above the ceiling. The containment material is extruded aluminium framing with clear polycarbonate panels for easy visual inspection. End-of-row doors on the cold aisles are self-closing with magnetic catches to maintain the thermal seal. Every gap at the top of the rack or between sections is sealed with flexible brush strips or blanking panels. Any unsealed gap is a breach. Commissioning includes a thermal imaging survey of all joints under full IT load. Any cold aisle temperature above 25 degrees indicates a containment breach that requires immediate correction. Server racks on IRONGATE are 42U open frame units, preferred for co-location due to maximum airflow flexibility. With a 600mm width and 200mm depth, they provide the ideal balance of space and management. Each rack receives 2 power distribution units, a PDU on the A side and a PDU on the B side. The A side is fed from UPS-A and the B side from UPS-B. Every dual-corded server plugs into both. These are metered and managed PDUs. Each outlet is monitored for current, power, and energy consumption. This data feeds into the DCIM system for real-time capacity management and precise PUE tracking. The overhead cable management consists of 2 separate systems installed on independent trays at different heights. Power cables run 300mm above the racks, while data cables run at 600mm above. This vertical separation maintains the strict EMI isolation standards we established in the MEP first fix phase. Pre-terminated MPO fiber trunks are our primary connectivity medium for inter-row and spine connections. Polarity is verified on delivery. Correcting an error on a 144 fiber trunk later takes hours of rework. Every cable is labeled at both ends using our standard naming convention. Unlabeled cables are removed and replaced. In a live data center, an unlabeled cable is more than a mess. It's a decommissioning and incident risk. The schedule signal. Blank panels and labeled cables are the difference between a PUE of 1.3 and 1.8. On IRONGATE, we had a zero tolerance instruction on 3 items: unsealed gaps, unlabeled cables, and missing panels. These were tracked on a daily defect log with same-day resolution required. No exceptions were made. Next episode, life safety, fire detection, suppression, and the most important button in the building, the EPO. Subscribe. See you in episode 14.